Hello, this is Professor Matt Katroulis, and this is the video for Experiment 2 in Chemistry 110 on the topic of conversion factors and problem solving. This experiment is going to be somewhat shorter than the previous experiment. We will talk about rounding and how that comes into play with significant figures. Then we will look at how to use significant figures in mathematical operations, first with multiplication and division, and then with addition and subtraction. We will look at how we can use equalities and create conversion factors from those. And then we use those conversion factors to convert measurements into different units. I'm going to start off by talking about rounding. I'm sure that most of you have rounded numbers before in the past. However, the procedure can be a little bit different in chemistry, and I want to focus partly on a review and partly on the differences that we will see. So first of all, to round a number, you determine the last digit that you want to keep, and we'll talk about that in a little bit more detail. That's where the changes come into play based on what you probably have already done. Once you've determined the last digit you want to keep, look one digit to the right. That would be the first digit you don't want to keep. If that number is 5 or greater, so 5, 6, 7, 8, 9, you round up. And that means that you increase that last digit by 1. From there, you're going to drop the remaining digits. And if the number is 4 or less, so 0, 1, 2, 3, 4, you round down, which simply means that you leave that last digit unchanged. And as I said, you drop all the remaining digit, or, and this is very important, replace them with zeros to avoid changing the place values. And that's what you have to do when the numbers are to the left of the decimal point. So a little bit more on that there. You want to, in doing that, not create additional significant digits. That's important. So be very, very careful not to move the place values of the digits. That can cause significant problems. So let's say you're asked to round 23.659 to the hundredths place. So first we have to locate the hundredths place. The hundredths place would be the 5. Now your rounding number is the number to the right of that. It's a 9. So 9 is a round up number, so that means you change the 5 to a 6, and then you drop all the remaining digits, assuming that ultimately you're not changing the place values by doing so. And are all the digits in the correct place value? Well, the 2 was in the tens, still in the tens. 3 was in the ones, still in the ones, so we're fine. No issue there. Let's do another example. Let's round 14,539 to the hundreds place. Now, normally we don't use commas in numbers when we're writing in chemistry. You'll notice that your lab manual instead inserts a space in between them. I generally will do neither. I won't use a comma or put a space in. So I have 14,539. Let's first identify the hundreds place, not the hundredths, the hundreds, and that would be the 5. The only digit we're going to be interested in to determine if that rounds up or not is going to be the next door digit, which is a 3. And so the 3 is a round down number. We take the 1, the 4, the 5 rounds up to a 6. Now these numbers, though, are to the left of the decimal point. Remember, there would be a decimal point right there, even if it's not written. So you cannot just drop them. You must replace them with zeros. So are all the digits in the correct place value? We really only need to check the first one and we'll be fine. So the first digit here is in the 10,000s place. this one would be also in the 10,000s place. The only time that that first digit would change is if, for example, this had been a 9 and the digit next to it made it round up, and then you'd have a 1. So that would add a decimal place. But other than that, nothing has changed. It would be totally incorrect to write 145. Just think about that for a moment. If this was your bank account, 14,539, and someone asked you to round to the nearest hundreds, $145 would be totally wrong. It's 14,539 would become 14,500. So don't forget that step. Now, as you'll see when we get into some of the calculations, instead of rounding to a specific decimal place, we're often asked to round to a specific number of significant digits. The way we do this is we count the number of digits that you want, counting from the left. Don't count any non-significant zeros that you might have at the beginning of a number, so you're only technically counting significant digits. Look one digit to the right of the last digit that you count. So if you counted 4 digits, you'd look at the 5th. And then we round using the exact same procedure. We use that rounding number if it's 5 or greater to round up, and if it's 4 or less, we round down. The same rule applies. Be very careful that you do not move around the place values of any digits. Let's use an example. Let's say we want to round this number, 539 10,000ths, to 2 significant figures. So I count the first 2 digits which are significant. So that 0 is a leading 0. I don't start there, and I don't start here. I start here. So 1, 2. So the 3 is the second significant digit. I want 2. So I look at the digit to the right. It's a 9. That tells me I need to round the 3 up to a 4. And so I have here 0.054. This, again, would not be 54. We need those zeros, even though they're not significant, to tell us the correct place values. So the 5 was in the hundredths place. It's still in the hundredths place. So are all the digits in the correct place value? Yes, they are. Do I have the correct number of significant digits? I wanted 2. I have the 5 and the 4, so I have 2. I'm fine. Here we have another example. I would like you to round 17,852 to 3 significant figures. So the first thing that we need to do is identify the first 3 significant figures. So none of these are zeros, so 1, 2, 3. The 8 is the third significant digit. The digit that we look at to determine rounding is the 5. So that is the decimal place, and we look at the 5, and it tells us we need to round the 8 up to a 9. So this would give us 179, but we can't change any decimal places. So I need to fill in zeros right there. So the 1 is in the 10,000s place. It is still in the 10,000s place. We have no problems. All the digits are still in the correct place value. Do I have the correct number of significant digits? The 1, the 7, and the 9 are significant. I have 3. Trailing zeros are not significant when there is no decimal point. So this is correct, 17,900. Alternatively, you could always write this in scientific notation. That would be 1.79 times 10 to the 4. So let me give you a chance to practice. So here are some numbers that you need to round. So 246.32 to the tenths place, and then round 32,391 to 2 significant figures. Write those down, pause the video, and carry out this rounding And when you're done, unpause and we will discuss the answer. Okay, so I'm assuming you've paused the video and you've solved these. So 246.32 to the tenths place. Well, the 3 is in the tenths place. I look at the number to the right of it, and it's a 2. So that tells me to just leave the 3 alone. We call that rounding down. And then you drop the 2 and anything else there. So 246.3. Are all the digits in the correct place? Well, that 3 was in the tenths place. It's still in the tenths place. The 2 was in the hundreds. It's still in the hundreds. We're fine. Now let's look at the next value. 32,391, and we want to round that to 2 significant figures. So the 3 is significant, the 2 is significant. Those are our first 2 significant figures. We look at the next digit to determine how we round. The 3 is a round down number, so that means we just leave the 2 alone. So this will round to 32,000. Why would 32 be the wrong answer? It does have 2 significant figures, and they are the first 2 significant digits. It is wrong because the place values have changed. This 3 is in the 10,000s place. Now it's in the tens place. This 2 is in the thousands place. Now it's in the ones place. You cannot do that. The digits need to remain within their same decimal place. So let's take a look at part A. And this is going to be one significant difference between this experiment and the previous one. I'm going to want to do this experiment in parts. So we'll do part by part. So part A. First of all, make sure that you've read the introductory material, especially page 11, and that you've gone through at least sample problem on 2.1, which is page 12, before you begin the rest. Hopefully you've already done that before even starting the video. Once you've done that, you want to answer question 1 on the pre-lab study questions, which is on page 17, and be sure to answer those in complete sentences. Now, for the remainder of the presentation, I might not ask you to come back to the pre-lab study questions, but before you do each part, look and see if you can answer the pre-lab study question and go ahead and answer them. You do need to finish these before the end of the experiment. Read the instructions for part A on the top of page 15. That is the procedures section. And the way these instructions work was that you're going to be given some values where a student was supposed to round 4 different numbers to 3 significant digits. So all of the values that you see should have 3 significant digits. And some of their results might be correct and others might be incorrect. So what you're supposed to do with that table is say yes or no as to whether or not they're correct, and that's on page 19 of the report sheet. And if you say no, you need to give the number rounded correctly. So let's take a look at some examples. So this table looks similar to the one on page 19, except it's a bit more colorful. So remember, the student is supposed to take this number, the number that they're given, and round it to 3 significant digits. So let's look at this and see if it's correct. Well, 3 significant digits would be, you keep the 9, the 7, and then the 6 is the 3rd significant digit. Remember, the starting 0 is leading, so we don't count it. 1, 2, 3. Oh, they kept 5 significant digits. They added zeros at the end. So they do not have 3 significant digits. They're incorrect. Not only that, what else have they done incorrectly? The 3rd significant digit, 976, is a 6. Next to it is a 1, and the 1 is a round down number. So they should not have rounded the 6 up to 7. So they should have just kept 0.976, and then to round down means just leave it alone. So 0.976. Don't forget to check that none of your values have moved into an incorrect decimal place. So the 9 was in the tenths place, it's still in the tenths place. We're fine. All right, the next one, 18,912. The student rounded this to 189. What they did was they looked and they said 1, 2, 3. The 9 is the third significant digit. They are correct on that. The 1 is a round down number, so they are correct about that. But this is not the correct answer because they've changed the place values. This 1 is in the hundreds place. The 1 should have been in the 10,000s place. So they forgot to fill in the necessary zeros here. 18,900. Should they add a decimal point? No. If they add a decimal point, that would make the trailing zeros significant. Then, instead of having 3 significant digits, they would have 5. So please, carefully look at the table on page 19 and complete it, going through it exactly the same way as what I did here. I'm going to go ahead and pause that, and when you're ready, I will continue on to talk about the material we're going to need for Part B. I'm assuming you've now finished Part A and are ready for the material for Part B. So we're going to look now a little bit more in detail at significant figures, also called significant digits, and we're going to look at how multiplication and division handles the changes of significant digits. So there are very clear rules as to how you're going to carry out multiplication and division, and those rules are going to be different from the rules that you're going to look at for addition and subtraction. So let's first start off with multiplication and division. So what you do is you carry out multiplication or the division as you always do, either using it in your calculator or doing it by hand or doing it in your head if you're able to do that. And you're going to get what I will call the calculator answer. That could be the answer you got in your head, but I'm just going to call it the calculator answer. Next, go back, count the number of significant digits of each measurement that you multiplied or divided, and ignore any exact numbers. That's especially true if you see any ones. If you just see a 1, you want to ignore how many significant digits it has. That's almost always an exact number. And then round your answer to the same number of significant digits as the measurement which had the least or the fewest number of significant digits. So let me say that again. You count the number of significant digits of each measurement that you multiplied or divided. So let's say one of the numbers has 2 significant digits, another has 3 significant digits. 2 is the smaller number, and so you would round your answer to 2 significant digits. Now, as with most things in chemistry, this is probably easiest to understand after looking at an example. So let's say you're given the following to calculate. 12.5 times 86.52. I'm assuming these are all measurements and none of them are exact numbers. So I put this into my calculator, and my calculator answer is this number right here, 1081.5. Now we have to say, well, this is probably not going to be the correct answer to report. We need to look at the significant figures. So this number here, 12.5, this has 3 significant digits. All non-zero digits are significant. And same rule applies here. There's 4 non-zero digits, so there are 4 significant digits. So we ask ourselves here, 3 or 4, which is smaller? 3. So we round this number to 3 significant digits. So how do we do that? Well, the 1, the 0, the 8. The 8 is the 3rd significant digit. Next door is a 1. That's a round down number. So we're going to keep the 1, the 0, the 8, and then making sure not to change any place values, we're going to need to replace that 1 with a 0. Is the 1 still in the thousands place? Indeed it is. So the final answer here is 1080, and we have 1, 2, 3 significant digits. That's because the 0 in between the 1 and the 8 is significant. A trailing 0, a 0 at the end, is only significant if there's a decimal point written, which there is not. Let's take a look at another example. This calculation here involves division, so we have 12 divided by 2 times 3. Since these numbers are all relatively easy to deal with, we can do this in our head. So we have the denominator here, 2 times 3 would be 6, and so 12 divided by 6 would be 2. And if you did this correctly in the calculator, the answer would just be 2. It wouldn't give you anything else. We can pretty much tell already that that's not going to be correct because it only has 1 significant digit, and all of these have well more than 1 significant digit. So the 2.0 has 2 significant digits. These are all trailing zeros in a number with a decimal point. The 12.00 has 4 significant digits, and the 3.00 has 3 significant digits. So if we look at all these numbers, 2 is the least number of significant digits. So this is kind of strange. We have to go from 2, which has only 1 significant digit, to 2 significant digits. So the way we would do that is simply to tack on a decimal and a 0 to the end, 2.0, and that has 2 significant digits in it. Correct? Yes. We couldn't add a 0 and make 20 because that would change the decimal place of the 2. You can't do that. So 2.0. Now, at this point, some of you might be going, but, and complaining about the answer I got in the last problem. And trust me, I was anticipating that. So if you haven't already done this, please carry out this operation in the calculator. Then ask yourself, did you get the correct answer, which is 2, or did you get 18? Well, the way this is written is understood to mean take 12 and divide it by 2 times 3. Now, if you put this in your calculator as 12 divided by 2, that would give you 6. And then times 3, that would give you 18. And that is not the correct answer. Again, it's understood that whatever is in the numerator has to be done on its own, and then whatever's in the denominator has to be done on its own, and then we carry out the calculation. But we don't want to do those as separate steps. So ultimately, we need to say that the 2 needs to be multiplied by the 3 to get 6 before the division is carried out. And the calculator won't do that. The calculator follows order of operations. And remember, the order of operations, PEDMAS, says you first do what's in parentheses. There's parentheses here, but there's nothing in there. Then you do multiplication, you do exponents, but we don't have any exponents here. Then you do multiplication and division in order from left to right. So if you just say 12 divide by 2 times 3, it would give you 18, and that's not what this notation is telling you to do. So there are 2 solutions for this. Number 1, you can enter the calculation with parentheses around all the calculations in the denominator. So you could say 12 divided by parentheses 2 times 3. Okay? If there were more numbers in the numerator, you could put those between parentheses as well. That's not the most efficient way to do it. The best way to do this is to multiply all numbers in the numerator and then divide by all numbers in the denominator, and that will give you the correct answer. So we would have 12 times anything in the numerator, but there's nothing else in the numerator. So just 12, divide by 2, divide by 3, just like I have it written here. And think about this. 12 divided by 2 is 6. 6 divided by 3 is 2. That is the correct answer. Now let's take a look at the rules for addition and subtraction. And I definitely don't want you to forget the multiplication and division rules, but just put them somewhere aside in your brain, because these rules are totally different from the rules of multiplication and division. I do not ask you to count how many significant digits there are, and if you do, you're doing it wrong. So instead, what we do is we look at the place value of the last significant digit in any of the values that you're adding or subtracting. And then you will round your final answer to the place value with the largest magnitude. Now that can be a little difficult to understand, so let me explain it in more detail here. So when I say this, what I mean is the decimal place more to the left is of a larger magnitude. So tens is larger than ones, and ones is larger than tenths, tenth is larger than hundredths. So let's say I ask you to do this. I ask you to add 15 and 9.8 milliliters, and that would be 24.8 before we deal with significant figures. So look at the last significant digit in 15. It's the 5, and the 5 is in the ones place. In 9.8, the 8 is the last significant digit, and it's in the tens place. So which of these has larger magnitude? In other words, which one of these is more to the left, the ones place or the tens place? Well, it would be the ones place. So you would round to the ones place. You'll also find it's going to be the one that gives you the least amount of significant digits, because we have to round more with this one. So the correct answer would be 25. How did I get that? Well, the 4 is the ones place. Next door is the 8. That tells us we need to round up to 25. And you'll notice I never count how many significant digits there were. That's not an issue in addition and subtraction. Now, it turns out that the 15 has 2, and 9.8 has 2, and 25 also has 2. And that does happen fairly often, but it is just a coincidence. The number of significant digits doesn't matter in addition and subtraction. So this one's a little bit trickier to understand, so let's again look at some examples. So here's a calculation. I have 13.55, 12.4, 0.325, and I'm wanting to add these all together. So I can add those in the calculator, and the calculator gives me 26.275. So let's go ahead and find the last significant digit in each of these values. So in 13.55, it's in the hundredths place. And then in 12.4, it's the 4, which is in the tenths place. And then thousandths place for that 5. So which of these is the highest magnitude, or the more to the left? Tenths comes before hundredths, comes before thousandths, so tenths. We're going to round this value here to the tenths place. So 26.2, the 7 tells me we need to round the 2 up to a 3. So 26.3 would be the final answer. Let's go ahead and take a look at part B. You want to go ahead at this point and answer the questions in the pre-lab questions that you feel able to answer. Now let's talk about part B1. So first it asks you to carry out calculations with only multiplication and division, and then write the answer with the correct number of significant figures. You'll want to be very careful on the last one, and that's why I went over that one exercise that had the 12 divided by 2 divided by 3, because those two values in the denominator, you either need to divide by them or put them in parentheses to get the correct answer. Part B2 asks you to use calculations involving addition and subtraction, and write the answer with the correct significant figures. And remember that you care about the decimal places with addition and subtraction. You should not be asking yourself how many significant digits there are when you're doing that. For part B3, you're going to need to use your ruler, and to do that you'll need to find the length and the width of the rectangle on page 20. And even though it doesn't ask you to do this, I'd like you to label those on the rectangle as well, the measurements. and make the longest side the width. So what I would normally call the height, make that the length. And then follow those instructions as given and report all the values with the correct units. You should know at this point that to find the area, that's simply going to be the length times the width for a rectangle. And then do cross out the part that asks you to put in another student's measurement. But I do want you to answer the question below that says, why could 2 students? You don't need to have another student's measurements in order to be able to answer that question. Part B4 asks you to determine the volume of a solid. And I'm going to show you pictures of that in a moment. And the shape that I'm going to use is a rectangular solid. And the formula for finding the volume of a rectangular solid is included earlier in the lab, but it is just length times width times height. And where you're asked to write the dimensions to measure, you want to write down those words that you need. So do you need the length? Write length. If you need the width, write the width. So write down the names of the dimensions that you need to find the volume of a rectangular solid. And don't forget your units when you're going ahead and writing down the measurements. So base your measurements on the pictures that you'll see. And I just gave you the formula for the volume of a rectangular solid, but it is written in the instructions. And make sure that you have the correct units, as I've already said. You must show the calculations with the units because you're instructed to do that on the report sheet, and you will lose points if you don't do that. So here are the pictures. Whoops, we're missing one picture there. So here is the height. And to make this easier, I'm going to go ahead and blow this up a bit. And pause if you need to. And here is the length. And again, pause if you need to. You're just looking right here. Make sure you're going to the right number of decimal places. Each of these markings is the 10th place. So you go 1 decimal place to the right. Don't forget that. We spent a ton of time doing that in experiment 1. And then finally, let's take a look at the width. And again, make sure, same ruler so that you're going to the correct number of decimal places. I'm going to go ahead and end this video here, and I will have another video which will go into the next parts, Part C and Part D. Thank you.